right, so welcome everyone to the NeuroKidz. Some of you were here last week, others welcome to this new year. I hope all of you are having a good day and everything went well at school. And so this is our second week, our second session. So what do you remember from our last meeting? Yeah, Shay? You can unmute yourself.
We watched a video about some parts of our brain.
Yes, we watched a video about some parts of our brain. It was basically an introduction to our program and what neuroscience is. So neuroscience is a really fancy word, but it basically is the study of our brain and how our brain controls the rest of our body. Like, how does my brain tell my hand to make a fist or to open it up again? So that is what neuroscience is all about. And last week, we also talked about how to join our Google Classroom. So I shared the link with your parents for joining the Google Classroom, but you will only be able to if you have a Google account. And you cannot use your school account. It has to be your personal account. But if you do not have that, that is totally fine. I'll still be sharing all the things with your email, with your parents' email, and I'll still be sending the recordings through email as well. Yes? Does anyone have a question? All right. So before we move into the stuff about our brain, here is a really cool math trick. All right. So this relates to neuroscience because your brain is able to do these really cool stuff. So, how many of you know multiplication? Raise your hand if you know multiplication. Yeah? So, someone type in the chat. All of you type in the chat. What is 1 times 1? Yes, it is 1. Can someone type in the chat, what is 5 times 5? Or all of you type in the chat. What's 5 times 5? 25. Yes. Now, here's the tricky part. What is 15 times 15? That's pretty hard, right? Like, how are you going to be able to do all this mentally, like without a calculator? And if you're going to be doing it by hand, you have to show a whole bunch of work, and that's not fun, right? But there is actually a math trick that you could use to figure out what is 15 times 15. Okay? So, if you multiply 5 times 5, you get 25, right? And if you multiply, so the 25 will always be at the end of a number when it's multiplied by itself and its last digit is 5. So like 15 or 25, it will always end in 25, okay? And then the first digit of 15 is a 1, right? So you multiply the 1 by the digit that's 1 greater than 1, which is 2. So what's 1 times 2? Can someone type that in the chat? 1 times 2.
Somehow, the chat is changing me to Isabella privately instead of everyone.
So yes, everyone has written 2. Good job. Now what we do is we put the 2 and we put the 25 and we just smack them together into one number. If we put a 2 and a 25 together, what do we get? What 3-digit number do we get? Just put the 2 right in front of the 25. It's a 3-digit number. 225. Yes, that is 15 times 15. So that's something really cool because you already know what's 1 times 1, what's 1 times 2, what's 5 times 5. All you have to do is just put them together and then you get 225. It's something you'll be able to remember that when you do like a little bit more practice. But for today, we'll move on to something else. All right. So in this picture, you can see that there are these 3 gummy brains. If we were in person, then you would have been able to see these in person. But since we are virtually, I have some pictures. So what do you all notice on these brains? Brianna, can you unmute yourself?
They have, they look like watermelons, but then in the middle, they have these like, kind of sort of like candy inside of them.
No, I'm talking about like the shape. What do you notice about the shape? Yeah? Oop. Oh no. My slides are malfunctioning. Oh, and there are some people I have to admit. All right. Isabella?
I noticed that there's a split in the middle.
Yes, it is split in the middle. What else do you notice? Shay?
It's a brain.
It's a brain. It has little wrinkles and stuff, right? Brianna, your hand is raised. What more do you have to add? What else do you want to add, Brianna?
They are circles.
Yes, they're kind of circular in shape. They look like brains. So they have wrinkles and it kind of looks like it's split in half, right? So that's kind of like how a brain looks like. So what are all those wrinkles? So you can see they're like little hills and valleys. So the tops of the hills are called gyrus. Can you all say gyrus?
Gyrus.
Yes, gyrus. And the little valleys are called the valleys are called a sulcus. You can say sulcus while you're muted. So you know how to say it. Sulcus. Really fancy words.
Sulcus.
And that big crack all the way in the middle of that brain is called the longitudinal fissure. That's kind of what separates our right hemisphere and our left hemisphere. Remember how last time we talked about how our right half of the brain controls the left side of our body, and the left side of our brain controls the right side of our body. So it's kind of like switched up, and it's really cool. So that's what those wrinkles are called. So why do we need those wrinkles? We need those wrinkles because they basically increase how big the brain is. There is more area to be able to think. So if you were if you were another animal, you might not have that many wrinkles, and then you might not be able to do some higher thinking. So the smarter you are, the more wrinkles you have. So if you want to become smarter, then you have to start growing more wrinkles in your brain. And that can only be done through practice and really working your brain so that it can grow and make those wrinkles to be smarter. You know that scientists, they actually saw Albert Einstein's brain, and they saw that it had so many more wrinkles than a regular human being, which showed that he was like so much more smarter than everyone else. And that was true because we think of Albert Einstein to be a genius. So that's something really interesting about wrinkles. Now, here's another thing that's really important for neuroscience. What are neurons? So neurons, it sounds a lot like neuroscience. So neurons are brain cells. They're basically the little things that make up our brain. But what are cells to begin with? Can someone answer that? Anyone can unmute.
Those are like your brain, but they like your cells. Like I think they keep track of memory.
These neurons, they are special cells. Yes, they're able to help you with memory. So, but cells in general, they're basically individual units that make up your body. So if you see this picture in the bottom right-hand corner, it's kind of like what a cell looks like. But cells, they're in all sorts of shapes and sizes. So that neuron that we saw, that one is really long. But this one in this picture, it's nice and round. And that all depends on what part of the body it's in. So if it's in the brain, the cells are all very long. If it's cells that are in your skin, then the cells will be really flat. That's why your skin is flat. And if there are cells in your blood, they would be more circular like this. Okay? So the brain is made of matter. The brain is made up of these neurons or nerve cells. So our brain is made up of gray matter and white matter. So gray matter is neurons that are without a covering or insulation. So if you see this cable over here, let's get this cable. Do you see this wire cable? It's a little charger, right? So on the outside of a wire, there's this rubber that's surrounding all the metal part. And this rubber, that's kind of like myelin, which surrounds some nerve cells. So the nerve cells that are surrounded by this insulation, this little covering, that is white matter. And gray matter, it's just the regular wires that are without that covering. So in this picture at the bottom, you can see that the brain was cut open. The gray matter is on the outside, and the white matter is on the inside. All right, so a quick recap, because I know that was a lot. So it was just an overview of the brain, the neurons, we learned the math trick, we learned about gray and white matter, and we learned about sulcus and gyrus. So if you have any questions and you do not understand something, please let me know, because this is an environment where it's okay if you don't know something, And I don't expect you to know these in the first place. And it'll probably take some time for you to know them. But this is all just informative. It's not like you have to know these. But if you do want to know them and you don't understand something, then please ask me. All right. So we're going to try to watch this video. Oh, well, I guess this isn't working. So we will move on. Okay. So we are also going to learn about brain protection and brain injuries today. So brain protection. Let me exit out of this first. Let's click present. So brain protection is something that's really important for everyone to know. Can you think of examples when you were trying to protect your brain and your head? You can unmute yourself or type in the chat. Anyone? Chat. You can wear a helmet. Yes, exactly. That is the answer that I was looking for. You wear a helmet to protect your brain. But our brain protects ourselves naturally. So how is our brain protected? We have a skull made of bone. If you knock your head, it's kind of hard, right? That's because we have a skull. We have a bone around our head. Yeah, if you knock your head, there's all that bone over there. And it acts like an armor. You know how soldiers have metal armor that protects them? That's the same thing for your brain. Now, there is a layer that's called the meninges. The meninges, it's a very fancy word. It protects the brain from being scratched by the skull, because the skull, it is kind of hard, and if you get scratched by it, the brain could maybe be harmed. So this meninges, it's made up of 3 thin layers. You can think of it as 3 stacks of paper put together. So there is the dura, the arachnoid, and the pia. You can say them out with me while you're muted. So the dura, and then the arachnoid, and the subarachnoid space is filled with cerebrospinal fluid. That's basically kind of like water-ish. And your brain, it's floating in liquid. That's crazy, isn't it? Your brain is basically floating in liquid. And it's protected by all of these layers. And that's how your brain doesn't get harmed when you knock your head. But your brain can get injured if your head gets hit hard enough. So how can your brain be hurt? In a lot of ways. Something can hit your brain, like if you fall or you have a car crash. This is why when you ride a bike, you must always wear a helmet, because you can fall and hit your brain. Or if nothing hits your brain at all, which can be a stroke. And that's when the blood is blocked from the brain and it cannot give it oxygen. Oxygen is something that is really important for all of us to survive. And the blood is what carries the oxygen to all the different parts of the body. So if your blood cannot get oxygen, then it can die. And that's what the stroke is. Or it could be through infection. So something infects your brain. So how to protect our brain? We wear a helmet when biking or on a motorcycle. You have to drive safely when you're older, of course, or have your parents drive safely. You have to protect your head and your face. Like, for example, in an earthquake, you know how they have, in an earthquake drill, they have you cover your head and your neck. So that when you cover your head and your neck, you're protecting your head and your face, and that's how to protect our brain. And just be careful in general. So, what did we learn? Can someone tell me what they learned today? Can unmute.
We learned today is like protecting your brain.
Mm-hmm. Yes, you learned how to protect your brain. What else did we learn?
You better wear a helmet when you're riding a bicycle or...
Yes, we learned about wrinkles. We learned about wearing a helmet. Good. What else did we learn?
Then we learned how to protect your head from riding a bike without a helmet because you could hit your brain.
Yes. So that's pretty much it for today. Thank you so much for attending.